Good afternoon, everybody. This is Jack Long, the Mad Scientist, and today's video is going to be a departure from my normal style of video. I'm actually going to be doing a machine review, first time ever. So a friend of mine reached out to me and he bought a Cantek four-sided planer and wanted me to just swing by his shop sometime when I was in the area and go through the machine and look at it from the point of view as a former woodworker and as a machinist and give him my opinion on it. So with that being said, let's jump into it. Alright, so we are going to do a machine review from a technician's point of view versus a sales pitch. We're just going through and take a look at this Cantek S4S planer, and it appears to be an M412 is everything, all the documentation that we have on it, and I'm just kind of go through and take a look-see and get a feel for it, see what's good, what things we need to look for, things of that nature. Recently got this thing under power, so we've been playing with it for just a little bit, and let's give her a walkthrough and see what we got. Looking at the control panel, obviously up in here we have some thicknesses and feedback. Sorry, can't speak here. Our feed, start and stop, bottom head, left front, right front, top, and as a point of reference, we have 4 heads in this. We have a joiner head. It's over here. We have if we were standing at the right side, this would be our right head, and then our left head, and then the cutter head in the back. And this machine was upgraded with the spiral heads, both on the top and on the bottom, which is a nice upgrade if you're doing a lot of planing and you want to be able to always have sharp tooling without having to pull your knives out, do all the surfacing with it. But the really nice thing is that the original heads are here in a crate. So we can actually see what would come from the factory and take a look at these. And I got to say, I am very impressed with what we see here. So this is a standard straight knife, nothing overly fancy with the straight knife. But one of the things that you'll see in this is that it has the old style with a gib and a jack screw. So where that comes into play is as you're changing your knives out and your knives get ground and come back, they have a tendency to get bowed just because of the heating of them when they get ground, stuff like that. So you can go in and you can tune this and bring these knives back straight. And comparison to some of those that, like the newer styles that you see a lot of the Asian imports, have the little spring gibs in them, and when you snap them they kind of come up and you kind of fight to get the alignment of the blade to be true. But this one actually has the old traditional style gib screws and jack screws, so that's really nice. This is still Cosmoline covered, so I'm going to be careful about how much I am actually handling this so I don't take the protection off. But you'll see on here, you'll see these radial lines. It's going around the circumference of the head, and that is so that when you pull out, and I'm not sure how well this is going to show up because I can't see on my camera monitor all the different profiles that you can put in this. Now, take in consideration that this is similar in concept to like the Woodmasters and I can't think of the other brand now, but anyway, so you go put the knives in, and it's much more tedious to put the knives in by hand and get everything tuned, but you're also not running production runs like you would like on a superset molder or a winding molder, you know, any of the big boys. So when you go to set them up and you're putting them in here, you've got those lines on those heads so that you can go in and tune them. And of course, then you can switch these out. These have look like insert. He's doing S4S, so we're not too concerned about profiles here. And as far as the material, as the material is being introduced, let's take a look, and we'll just start from the front. We have a traditional fence. If you've ever ran a Moulder, you know you got an Infeed fence that you can move to the left and to the right. We have the same thing here, and it has a locking handle and an adjustment that we can slide that, and it seems to be pretty robust. It doesn't look to be, you know, chintzy. The mechanism, if you can see the cantilevered arm here for it to pivot on, and a nice scale that you can see how much you're taking off. The first head is set from the factory so that it automatically lines up with the outfeed table here. I did go in and take a look mechanically to see if there was any vertical adjustment to offset the head to the table, and there's not, which is nice because if there's nothing to adjust, there's nothing to screw up. So once you get that put in there, you are golden. The question that you may have is that when you are doing that style head, is that how can you get those knives tuned? And that's when you are going to come in with a gadget like this, and we'll spend some time with this scale. I use this a lot for my sanders. It is a multi-gauge, not a sponsored product, just something that I happen to use. It's cost effective, not terribly expensive, and when you put it down on a table surface, you set your dial indicator, and you can see if you can see my needle moving up and down here. We took this roller out, and we could use that to line up against the head and see what the projection of the knife is in relationship to the table. But he has the square inserts in here, so that is a moot point. We don't need that. The other nice thing about this, kind of makes it very, very simple, is the infeed table, the quantity that you can take off. If you think of this as a joiner, so this would be our infeed table. We have a couple screws here, and then we have these plates. And you just basically add and subtract plates to control the quantity that you're taking off at the beginning. So if you've ever had a joiner and the tables have a tendency to get wonky over time unless they have sliding dovetails, this eliminates it. And yes, we just heard from the boss. Hey, boss. We just heard from the boss. So the boss is over there making sure we're staying in line. So coming into this, we have 3 rollers here that are spring loaded. That maintains position, keeps your material pushed up to the side. An outfeed fence that we have going across here that looks like the surface of that outfeed here is it's a metal fence. I can't tell what species of metal. I thought it might have been phenolic, but it's not. It appears to be metal. And you can adjust this fence left and right in relationship to your first head or your second head, which would be your right hand side. Left is we're standing at the outfeed. And just like on a traditional Moulder, you're going to move it in and move it out in relationship to your head. Now I know on a traditional Moulder you can tune the head in relationship to the fence, but on this we're moving the fence in and out in relation to the head. The opposite side on this one, we have a guide here. This is let's see what we got. We got round rails. It's down here, which is nice because round rails are inexpensive to produce and they're very robust. You can see them all the way up through there. Nice round rails. We have an adjustment here that is for your size that you're producing. And then we have an outfeed roller that's here. And you can see it's spring loaded. So as the product goes out, it does not have a chip breaker, does not have a pressure shoe. So if we have any of the problems like with the snipes and stuff like that, our ability to maintain tension and position is going to be this roller here. When we get into the top head, it is similar. We do have a chip breaker for the top head, spring loaded, and at least on this particular machine, it is not segmented. So it's a straight bar all the way across. And no hold down in the back except for a roller. So it doesn't have a hold down shoe. And I can tell you from experience, from my past experience, like Williamson Hussey, that was the name I was trying to think of a while ago. When you use a roller like this, it's more forgiving when you're doing some of your profiles. So if you had the other head in here and you were doing profiles, this is more forgiving on some of your product. Okay, what other gadgets we got in this? Let's go on around the other side. Let's take a look. Let me get this out of here so I don't forget it.
Speed.
Thank you. Yes, speed. The feed rate is a mechanical gearbox, which is nice because that means there's no inverter to drive it. It's nice and mechanical. It's going to be a oil-filled box. You're going to change this speed while it's running. It does have a scale on the side.
It's 10 to 46 feet.
10 to 46 feet. That's what I was just told on it. And we have a limit switch here appears for our thickness to keep us from going too thin. We have another switch down here for going too thick. The outfeed and infeed table. Sorry for that. The infeed and outfeed table are in addition to it as far as not casting, which is okay because this is a support table. And then, of course, the back of the machine. And here in a moment, we may jump in there and take a look at some of that, but we're not going to do that just this second. One thing that needs to be noted on this is Jason here has shortened up his infeed table, and that's his personal preference because this where I'm standing at is a walkway and an aisleway, so he chose to shorten this up. It's how much to take it off? 20 inches?
Yeah, 2 foot roughly.
So he cut that section off. So if you're ever looking at it, it would be, you know, another couple feet out. But for him, this real estate's expensive to him, so he chose to shorten that up. Appears to be bed lube, which is nice. If you've ever ran a Moulder, you know you need bed lube. And I think at this point what we're going to do is I'm going to see if I can talk him into starting it up and let us run a little bit, and we're going to see how she puts parts through there, and I may, depending on how comfortable I am, put one of my dial indicators in here to go in and see how consistent it is. We'll put a dial indicator on it and see how repeatable the profiles are as they're going through there, just for kicks and grins.
Hey everybody, it's me again. I just need to jump in here real quick and apologize to everybody. The quality of this audio in parts of this video is just horrendous. As you know, I am a machinist, former woodworker. I'm not in any stretch of the imagination am I a video guy. I just happen to be a guy with a camera and a nice little budget that my wife lets me spend on my toys. And I'm working my way through these audio problems, trying to get everything lined out. This set of microphones that I'm using, to say that they are bad doesn't do them justice. And they have a wonderful review online. Everybody uses them. Clearly those people don't work in shops. So I have to apologize, and I'm even doing a little talk over here as the parts are going by, because it's just so disappointing. It does clear up as we go through this, but for right now, I just really have to apologize.
Okay, so he's saying that this is coming out right now is 2.5 inches. He wants it to be 2 9/16. So we're going to make an adjustment, or he's going to make an adjustment here. And he's going to open it up, locking handle down below. Join your head. looks like to me that we're not taking any material off this back head now. And we're removing too much here on the beginning. He agrees. So one of the things that he and I was discussing before was aligning this guide, the second guide, which is tied to here, aligning that using a straight edge so that he can basically treat it the way we would do a traditional joiner. So what he's going to do now is he's going to take his Infeed and make it physically cut that just a little bit. Once we get done with these adjustments, we'll be back. All right, so Jason just shows another neat little thing. He's got here a little switch here that when it's moved to the left, you'll see the icon where the feed is intermittent versus here. And when it's over on the left-hand side, it allows you to see if you can see the rollers up in here. Go underneath it. Right here. See where it's bumping. So it's just jogging. So that's nice. And what we're going to do is we are going to introduce the part until it goes through all the way past the fourth head, but not past the first head. And then we're going to stop it and extract the part and see how each cutter head is cutting. Sorry about the dust structure. It's probably literally right above my head. Now we're cutting well off the left. Cutting just a touch here on the right hand side, just barely. I am quite impressed. Okay, so we're going to pull my light out of the way there. We'll extract this part. So before we take this out, we'll take a look at this here, and you'll see it does not appear that our top head is cutting anything. Which is okay. We're just trying to figure out what we're adjusting and where and why and all that for right now. And we are taking off a measurement here, which is this adjustment that we did down here a while ago. And he made a adjustment to the Infeed Fence to make it cut less because we thought that the available materials that came in was too narrow for this adjustment to actually cut anything. And it needs to come back just this way. Now, we could see this as it was running, that this is taking off. It might be taking off a 64th, but we'll know here shortly, because what we're going to do is we're going to extract this part by hand and then go through and measurement and figure out all of our numbers, what's right, what's wrong, and get an idea how the machine is running. So we did a storage stick, and it's through here. This is the way it came off the machine, and you can see we were cutting with our joiner head, and this cut was made after he made an adjustment to this fence to try to offset a little to the right, and he moved it as per my instruction, which was, I believe, a little too much. So, you know, that's typical. Don't listen to the technician because we don't know what we're doing. So we moved that over, and as it's coming through here, I'm now feeling the edge that should have been produced by this, and I can feel in here that it is cutting, because I can feel the knife marks that's left from the kerf from before, but it is very, very, very light. Not enough to get excited about. Then the amount that's being cut off from here, obviously you can see from this. So when we went through and we measured this, it's coming out after that head at 855. 855 thousandths. It's going in 962. His goal in thickness is 813. So he wants this to be 13/16. Problem is that we're taking so much material off here that there isn't anything for here. So what we're going to do is we're going to go in. We want to know what this offset was, so we can adjust this plate
If you recall back at the very beginning, we talked about this plate. So he's going through and he's doing some research on to determine which plate it was. But the question is how much do we need to do? And for those of you that don't know how to use a calculator, your calipers are much easier to use if you set them up in incrementals. And then what you'll do is you go in, you'll take a measurement off one, and we'll get that set in there. Bear with me. I zero it out, put it at 0, and then you go over to the other side, and then you take a measure, and the difference between the two, 108 thousandths. Now, we did this just a few moments ago, and it was 960 thousandths. So it's measuring, we're doing wood, so we got a little bit of variance. But nonetheless, so this jointer head is taken off 100 thousandths, basically. So what we need to do is go in and remove these 2 screws, right here, and put the correct plate in there. Once we do that, he's already made an adjustment to this. Then we will repeat this test and measure all these things again. And hopefully, as we start to get this moving up, we'll start to bring that back head into play, and then we can see what our calibration with our scale here actually is. Because we know we're going to need to tune it a little bit, but right now the top head's not doing anything. We have no idea where it's at. And let me get you set in here, and I don't know how much you'll be able to see because we are kind of limited on space. And get you tuned. Come on, release. Turn down in here. So as per the instructions, they say that we have 3 plates, and one is 1 millimeter, 2 millimeter, and a 3 millimeter. And by combining the different thicknesses, we can go anywhere from 0 if we stack all 3 together and stagger it in 1 millimeter increments all the way down to the maximum cut of 6 millimeters. So we've got these screws. Make sure I don't lose it because I'm actually working with the bad hand. Screws. Take the plate out. This machine still has cosmoline under the plate. Isn't that wonderful? And it was well taken care of. Okay, while he's doing that, I'm going to blow this off, and then we'll go over there and we'll take a look at those different plates. And it's not rocket science. Stack 1, stack 2, stack 3 to get our different quantities. Let's see, there's our 2, there's our 3, and there's our 1. We had a 3 in there, and we want to take off a 1/16 of an inch, which is 62 thousandths. We were taking off 100 with this one, so if we raise it up another 40 off of 100 is going to give us 60 thousandths. So if we take off 4 millimeter stack, it should give us a 1/16 on the bottom. Do you want that, or do you want to go? Do we want to put 5 millimeters off and take off about 30 thousandths off the bottom?
Just the low end work up. Except for nothing on the bottom.
Okay, we'll just put those 2 in there and try that. So the reason we're discussing this is he's getting some hit and miss planed product. Sorry, the camera's pointing the wrong way. Get this up here where it's at. He's getting hit and miss product, and one of his goals with this is not only for making his cabinet frames, but also his doors. So he's wanting to make sure he doesn't take so much off one side or not enough. You know, I don't have to tell you all this. This is all stuff that, as woodworkers, we all know. We mentioned to having the bed lube. These oil holes is what's different. They're not symmetrical. That's good to know. And I can really enjoy this, standing around watching other people work, taking videos. How can I get this job for a living?
Still be used to it.
Ooh,
Easy there, mad scientist.
yeah, it's that bad hand. Still haven't learned to hold anything with that finger yet. Right. So while we got all that together, about 3 months or so ago, I got that finger nabbed in a big 10-inch cutter, and it's not quite. Well, it ain't learned its place yet. Let's put it that way. So let's get all of our other stuff here out of the way. Make sure there's my tools, marker, his tools. As a point of interest, while he's gathering his stuff up here, if you ever wanted to go in and do micro adjustments to this fence, if you go out and look for the people that sell metalworking equipment, they sell these little magnetic based dial indicators. You see them a lot on metal lathes as the saddle is transversing across, and they reference the side of the saddle, but they attach to the base of the lathe. You could put something like that on here just so you could tweak this very minor amounts. I have magnetic based indicators in my box. Wouldn't be perfect for this, but if we wanted to get in and do some micro adjustments on it, we may get that out just to discuss principles on it, or maybe even come in with calipers or something so we can see the micro adjustments.
How well it showed up across the microphone, but he did notice that this back head is cutting. And just from what we can see here, while everything was ramping down, we do have a finish coming off of this now. That head didn't look like it was taking off much. As you can see here now, this one, we'll go in and we'll measure that.
All right, so follow up to this. My conclusions. I am impressed with the engineering that is in this. I'm especially impressed in this head. There's a lot in these spiral heads. There's a lot of technology in these that you really, if you ever get a chance to watch how they're made out on YouTube, it's very impressive if you're a machine geek. One thing that I can tell you, if you've ever had to change these out, is you want to make sure that you use torque wrenches to set them. Even though you can put them on a ratchet and just kind of crank them down. If you under tension these and they come loose, of course you're going to throw a knife. On occasion, what will happen is you'll get debris that will go up underneath your knife, and it will cause your knife to raise, and then you start getting the little inconsistencies in your profiles. If you've ever seen those deep grooves from a spiral head, that's what it's from. Debris gets under it. The worst part about it is that if you over tighten it and you fracture the carbide, and then as you're running, the carbide can break. It'll split in half. All right, so they're kind of fragile. So torque wrench and then torque it to the manufacturer's spec. A few things, observations in here that our feed system in here, they appear not to be using roller bearings. They appear to be using bronze sleeves. I'm not even sure if that's bronze, but nonetheless, it's like a sleeve bearing. And I'm sure they do that as a cost-saving issue. These aren't high speed, and sleeve bearings are certainly still used in engineering every day. So in this application, to save some cost, a sleeve bearing seems to be a very good solution to an engineering problem that can add quite a bit of money to to the project. I've seen that on both sides. In the planer head, let me get this board out of the way. In the planer head back in the back, we do not have a presser bar go across the back to support the material, so it does have a tendency to lift and snipe. In addition to that, our tables, extension tables, they are a stamped metal, and currently, because he's not too worried about it at this point, that they do fall off. And because they fall off, if I had a long piece that was coming out here, it's going to leverage off this and cause this tail to rise up a little bit, and we're going to snipe a little bit more. And of course, we had that at the beginning too. But in all fairness, this guy, he's not a terribly big shop, so he has the mindset and the time to work with the little quirks that goes with this machine. So given everything that we see here, and I'm not sure exactly what the price point is. Somebody sent me a price on one today, and I want to say they're in the 21, 22, 23 range for the base machine. And then, of course, this machine actually has an upgraded motor. That was an option when the original purchaser bought it. They changed the heads out. They've got options for putting in the knives. But for the base machine, I tell you, I would like to go through and poke at a bunch of holes in it and say, you know, this thing is a big paperweight. But I like it, to be quite honest with you. It does have some quirks, but if you know what the quirks are and you're really willing to work around them, like for instance, you raise the door up, the door then kills the control power, and we have lost our display here. And when we lose our display, if you crank this, then you lose your calibration. But it literally took us 30 seconds to bring the calibration back. And see, once it closes the door, it comes back, and there it is. We know what this quirk is. It's no longer a problem. I am extremely impressed that they have a simple jog feature on here that you just flip it over, and now your start-stop becomes a jog. That is very impressive. A master control switch, so you can kill all your control power. E-stop here. Mechanical gearbox for the feed. These are pretty bulletproof. This is a standard design that's been around for decades. I don't know if this manufacturer has, but this style has been around for decades. Operator panel, as he's showing here, spins around. Yeah, I tell you, I would like to go through and poke some holes in it, but you know, if you're looking for something if you're a billion-dollar company, no, this is wrong. But if you're a smaller facility,
500-foot shop.
Big pardon?
500, 600-foot shop.
Yeah, he's doing 500-600 feet, and as it's going through, because of the size of his shop and everything, he'll be doing quality control as it comes through, and he'll be measuring to make sure everything stays true, just because he's wired that way. I went through looking at the documentation and the American documentation, and I say that because this obviously is in English versus translated from Asian. The parts manuals, wherever we hit the parts manuals at, an idea of the parts manual. It's got a real good list of parts breakdown in it, the descriptions, and it goes into the schematics. Schematics are in the book. Yeah, I think it's a pretty good machine. What do you think?
I like it so far. We'll find out tomorrow when we run it through.
All right.
Thank you, Jack. Mad Scientist. Follow him on Facebook, Instagram. Cool dude. Love it. Thank you.
See you guys later. Be safe.